Okay, let's look at the last week's homework problems. So we were calculating the singlet triplet gap of methylene, and last week we have used calculators to calculate the gap, and that's not all a good idea, especially when you want to tabulate a lot of data and need to analyze them. So for that one can easily use Excel. I am using the Microsoft PowerPoint Excel, but you can actually use the Google Docs, and there's an Excel in the Google Docs. You can use that one for, and that will do the same purpose as what I am showing. So let me start a new Excel file. I start with a blank notebook. I copy my characters, whatever I have. Let's me to copy. There, this one was this cells I want to I can just write actually. Maybe I should give a different color. Maybe I write this one as Hattrifork. This one I should have avoided the color. Let me make it white again. This I should make it give a different color, maybe red. Okay, this one I should make it middle. This is MP2. And let me read my basis sets. And I can this is my Hattrifork energy for the singlet state. Hattrifork energy for the triplet state. And also let me take the MP2 singlet energy. And now I can calculate the triplet minus singlet gaps. A minus. It depends upon how you want to say that, triplet minus singlet or singlet minus triplet. Let make it singlet minus triplet. Minus triplet, and I want it into the kilocalorie. This is in Hartree, so I can use the Excel formulas. I can multiply with 627.51, that's the conversion factor. It's 30.86. The same thing I can do it here. Singlet minus triplet, and I can multiply with 627.51. So let us now run the calculation for other basis set and see how the singlet triplet gap changes. One thing is that the singlet triplet gaps actually becomes better when I go from Hartree Fock to MP2. To make that, what I can easily do is to manually edit this file. I already have the geometry. Week 3 I can go to the MP2 assignments. This is my CH2 singlet dev to SVP input file. Let me change it to CCPV. DZ, and let me save as, so that I don't overwrite my dev to SVP. Why I will save it everyone with a different name is that because if I have some problem in my analyzing my result afterwards, I can go back to my original input and output file and try to see if something has went wrong or not. So it's a good idea to put proper nomenclature for all of them. This will require more work, but will be more helpful. So this is CCPV DZ singlet DZ dot input. Let me save it. Let make the other input files at the same time, saves me some work. So this is DZ. I again go as save as. INP, and let's make the QZ and save it as this one, save as all files. So my singlet inputs are done. Let me go to the triplet now. Save as. CPV DZ extension. This is triple zeta. This is quadruple zeta. So now all my files are prepared. So let me now run Orca one by one. I think there is some naming problem. Let me check the names again. Singlet CC PDZ. I think we have not given the V for the case of singlet, but that's fine. CH2 singlet CCPDZ dot out. So my DZ is done. I can just change the keyword in the input and output file. This is my DZ. So a QZ can take slightly more time. Okay, so now all my calculations are done. I can open the output file. Let me start with dz.out. This is my SCF total energy. This is my MP2 total energy. This is CCPTZ output file. This is my SCF energy. Here it is. This is my MP2 energy. And this is QZ. This here is my SCF energy. Okay. Let's do the triplet calculation now. Vodka, CH2, CH2 triplet, CC PVTZ dot out. So, this is double zeta, let us do the triple zeta. And do the quadruple zeta. We have seen in the previous case also the quadruple zeta may sometimes take a larger time. What we can do then, we can open up the CCPV TZ output file and print out the SCF energies. This is SCF and this one should be below. Maybe TZ, this is TZ. MP2 energy, and last is the quadruple zeta. This is SCF. This is MP2 total energy. Now, what we can see from these numbers? Before we calculate the singlet triplet gap, so the first thing to see is that in all the cases, the value of the correlation energy is actually lower than the Hartree-Fock energy both for singlet and triplet. Second thing is that as I am increasing the basis set double zeta, triple zeta, quadruple zeta, my energies are now lowering down. And if you can see, the change from the double zeta to triple zeta is actually larger than what you see from triple zeta to quadruple zeta. That means it is converging towards the basis set limit. So, of course, one can go to a complete basis set limit, but here in this case you can at least see that the basis set, the values from change from double to triple zeta, triple to quadruple zeta, double to triple zeta change is more, and triple to quadruple zeta change is actually less. Second important thing, if you look it carefully, you may be able to see it, is that the change in the Hartree-Fock energy is with the respect to the basis set is smaller than the change in the correlation energy. If I have total energy on the MP2 level, if I have just plotted the correlation energy, the change would have been more obvious, I believe. Now let us calculate the singlet triplet gap. So again, good thing about writing in Excel is that you can use the same formula. Now, even in the singlet triplet gap, you can see that the changes are actually small as I go from double to triple, triple to quadruple, but in the case of the MP2, the changes are quite significant, and double to much larger than this one than the Hartree-Fock, and double to triple zeta there is a large change to almost more than 2 kilocalorie per mole. So, all these energies are kilocalorie per mole, and from the triple to quadruple zeta is less than 1 kilocalorie per mole. And if you remember what was my value is 9.12 was my experimental value. So, that means we are good, but we are still not up to what is called an experimental value would have got. Remember, there is another problem where we are supposed to calculate the couple cluster values for it. So, now let us try doing that one. So, if I calculate couple cluster CCSD parenthesis D, how the value should look like. I think I will just skip the def to SVP, I will just continue with the CCPV DZ, TZ and QZ. First, let us make the input files. What I can do is that I can just start with the already existing input file, and then change them to the, so this is so in place of MP2 for the singlet I have to write CCSD parenthesis T, rest everything will remain same. Let me write it in a different way, singlet DZ CCSD T, and I want to make it an input file. Similarly, I can make the input file for triple zeta and quadruple zeta, and let me start making the input file for triplet also. Triplet.inp. So, let us make the triple zeta and quadruple zeta input file, run it and then see how the results look like.